A paper published under the name of a National Academy of Sciences claims that objects 36 kilometres wide are moving across the surface of the Moon at 11 kilometres per second. If that were true, they would appear in a backyard telescope at almost exactly the same size as the planet Saturn. Not a speck of light, a visible disk crossing the face of the Moon in about 5 minutes, more than 20 times, over 2 months. And exactly one instrument on Earth recorded it. So today we're going to take that claim completely seriously, which means doing the one thing almost nobody who shared it did. We are going to check it. Because there is a second number in that same paper, printed by the authors themselves, that quietly destroys their own conclusion. If you want the arithmetic instead of the headline, hit like and subscribe. And drop a comment telling me where you are watching from, and whether you have ever pointed a telescope at the Moon yourself. Because if you have, you already know the thing that solves half of this. Now, let's get into it. Part 1. The number that cannot be true. 11 kilometres per second. That is the figure at the centre of this entire story, and I want to put it in front of you before anything else, because everything that follows is really just an argument about what that number means and where it came from. 11 kilometres per second. Roughly 24,600 miles an hour. That is the speed at which a paper published under the name of the Main Astronomical Observatory of the National Academy of Sciences of Ukraine says a ring-shaped object, roughly 36 kilometres across, was moving against the surface of the Moon. Hold that number in your head, because I am going to hand you a second one right now, and the second one is going to do something to the first. The escape velocity of the Moon is 2.375 kilometres per second. That is it. That is the whole number. 2.375. It is not a controversial figure. It is not disputed by anybody anywhere. It falls out of the Moon's mass and its radius, both of which we have measured to absurd precision, partly by bouncing lasers off mirrors that human beings physically carried there and set down on the dust. 2.375 kilometres per second is the speed at which an object leaves the Moon and never comes back. And I want to be specific about why that number is so solid, because when I say a figure is measured rather than claimed, I owe you the reason. Escape velocity depends on exactly two things: the mass of the body and its radius. We know the Moon's radius to within meters from decades of orbital laser altimetry. We know its mass from the way it perturbs the orbits of spacecraft we have flown around it, and from the way the Earth and Moon swing about their common centre of gravity. And underneath all of that sits lunar laser ranging, which is the practice of firing a laser pulse from Earth at the retroreflector arrays left on the surface by Apollo 11, Apollo 14 and Apollo 15, and by the Soviet Lunokhod rovers, and timing how long the light takes to come back. Those arrays have been sitting there for more than half a century, and they let us measure the distance to the Moon to within a couple of centimetres. So 2.375 kilometres per second is not somebody's estimate. It is one of the best constrained numbers in planetary science. So an object moving at 11 kilometres per second, measured relative to the Moon, is travelling at more than 4.5 times the speed required to leave the Moon forever. I want to slow down on that, because it is the kind of statement that sounds technical and slides past you, and it should not slide past you. Picture standing on a hill and throwing a ball. You throw it, it arcs, it comes down, you throw it harder, it arcs farther, it comes down farther away. Keep increasing the speed, and the arc keeps stretching, and if you could throw hard enough, the ball's downward curve would exactly match the curvature of the ground beneath it, and it would fall forever without ever landing. On the Moon, that speed is about 1.68 kilometres per second. That is orbit. That is what it takes to circle. Throw it harder still, past 2.375 kilometres per second, and the curve opens up permanently. The object does not circle. It leaves. Now put an object at 11 kilometres per second next to the Moon and ask what it is doing there. It is not orbiting. It cannot be orbiting, because it is going 4.5 times too fast to orbit. It is not hovering, because hovering requires thrust and a reason. It is not stationed there, parked there, or based there in any sense that the word base normally carries. At 11 kilometres per second, an object near the Moon is passing through, on a trajectory that opens outward and never closes, and it is gone. And the headline conclusion of the paper that reports that 11 kilometres per second figure is that the Moon is being used as a base. That is the shape of the problem. The measurement and the interpretation are sitting in the same document, contradicting each other, and almost nobody who shared the story ran the check. I did not run it because I am clever. I ran it because it takes about 90 seconds and a search for the words lunar escape velocity. So here is what this is actually about. It is not about whether there are alien machines at the moon. I cannot answer that, and neither can anybody else, and anyone who tells you they can is selling something. What I can do, and what we are going to do together over the course of this, is walk through exactly how you take an extraordinary number that somebody hands you and find out whether it holds up. Because the tools for doing that are not exotic. They are arithmetic, a couple of physical constants, and a willingness to ask the boring question that nobody asks, which is always the same question. How did you measure the distance? I'm going to be scrupulous about something throughout this, and I want to flag it now so you can hold me to it. There are 4 different kinds of statement in this story, and they are constantly getting mashed together in the coverage. There are things that were recorded, which is to say video exists and objects appear in frames. There are things that were claimed, which is to say somebody asserted an interpretation. There are things that were derived, which is to say a number was calculated from an assumption, and if the assumption is wrong, the number is wrong by exactly the same factor. And there are things that have been refuted, which is to say somebody did the physics and showed it does not work. I will tell you which is which every single time. When I say something is measured, I mean it is confirmed and not in dispute. When I say something is claimed, I mean somebody said it and nobody has independently verified it. When I say something is a hypothesis, I mean it is an idea worth taking seriously that has not been established. If I blur those lines, I'm doing the same thing the coverage did, and this whole exercise is pointless. So let me start with what is genuinely, verifiably true, because there is more of it than you might expect. The paper is real. It is called UFO Dynamics on the Moon. It is hosted on ResearchGate with a digital object identifier, and it is also available through the observatory's own website. The lead author is a man named Boris Gilyaev. He is a doctor of physical and mathematical sciences, and he headed the Laboratory for Transient Phenomena in stars at the Main Astronomical Observatory of the National Academy of Sciences of Ukraine, outside Kyiv. His listed collaborators on the lunar work include Vladimir Petukov and Sergei Pokhvala, described as technical staff at the same institution. None of that is invented. None of it is exaggerated by the people sharing it. This is not an anonymous account posting a video with dramatic music over it. This is a career astrophysicist at a national academy, with an institutional email address and a publication record going back decades, saying in writing that he believes the moon is hosting the machinery of a technologically advanced civilization. That is genuinely unusual, and I think it is worth sitting with for a second rather than rushing past it, because the reason this story travelled is not that people are stupid. It travelled because the credentials are real, and most of us have been taught, correctly, that credentials are a reasonable shortcut when you cannot check the work yourself. The whole point of this is that in this particular case, you can check the work yourself. And here is the thing I want to be very clear about before we go any further. Nobody serious is accusing anybody of faking footage. Not me, not the physicists who have taken this apart, and not, as you will see later, the review board at Gilyaev's own observatory, which used the word original to describe the observations. Something was recorded, objects appear in the frames. That is not the disputed part. The disputed part is what those objects were and how far away they were, and those two questions turn out to be the same question wearing two different hats. Because the paper says something else about these objects that is going to become extremely important. It says they are heavily camouflaged. It says they are nearly identical to the moon in colour and brightness, that they show contrast of no more than about 10% against the lunar background, and that they are effectively invisible without high-speed imaging and specialised variability analysis. They are, in the paper's framing, hiding. So the first real question is not whether they exist. The first real question is how big something has to be to look the way these objects are described as looking. And when you convert the paper's own numbers into the only unit that actually matters for a telescope, the answer is not subtle, and it is not small, and it does not look anything like hiding. Part 2, 20 Objects and 2 Classes. The observations were made across August and September of 2025, using high-cadence video of the sky immediately around the lunar disk. That phrase, high cadence, is doing real work, so let me unpack it. When you image the moon through a telescope, The atmosphere is constantly smearing the view. The standard technique for beating that is to record video at very high frame rates, hundreds or even thousands of frames, and then let software pick out the sharpest moments when the air happened to be still and stack those together. It is called lucky imaging, and it is the reason modern amateur photographs of Jupiter look better than professional observatory photographs from the 1970s. So the method being used here is legitimate and widely practiced. That is not where the problem is. Across those recordings, the papers report more than 20 distinct objects, and they sort them into two categories, which the authors label with terms that are, frankly, a little confusing on first contact. The first category is called atmospheric. These are objects that appear more or less fixed relative to the lunar disk. They flash. Each flash lasts between 100 and 500 milliseconds, so between a tenth of a second and half a second. The brightness change during a flash is given as roughly 1 stellar magnitude. That unit deserves a translation, because the magnitude scale is one of the genuinely weird holdovers in astronomy. It runs backwards, so smaller numbers mean brighter objects, and it is logarithmic. So each step of 1 magnitude is a brightness change of about 2.5 times. A 1 magnitude variation means the object roughly doubles and a half in brightness, and then drops back. If you were looking at a star that did that, you would notice. It is the difference between a star you can see easily and a star you have to work to find. The papers also report that these flashes are not random. They describe a fundamental frequency with harmonics on top of it, all clustered in the range of a few hertz, meaning a few cycles per second. In plain terms, the light is pulsing with a rhythm, and the rhythm has structure. That structure is one of the main pieces of evidence the authors point to when they argue these objects are technological rather than natural, and I want you to file that away, because we are going to come back to what else produces rhythmic brightness variation in the single-digit hertz range, and the answer is going to be uncomfortable for the technological reading. I should be fair about why the authors treat that rhythm as meaningful, because the reasoning is not stupid. A light curve, which is simply a plot of an object's brightness against time, is one of the most powerful tools in observational astronomy, and periodic structure inside one genuinely does tell you things. It is how we determine the rotation periods of asteroids that are far too small to resolve as disks, by watching an irregular lump tumble and reading the brightness rise and fall as different faces turn toward us. It is how we found the first exoplanets by the transit method, by catching the tiny periodic dip as a world crosses in front of its star. It is how we measure the pulsation periods of Kyiv variable stars, which is the rung of the cosmic distance ladder that let Edwin Hubble establish that other galaxies exist. Periodic brightness variation is a real signal carrier. The question is never whether a rhythm means something. The question is always whether the rhythm is coming from the object or from everything between the object and the sensor. The inferred sizes for this atmospheric class run from hundreds of meters to several kilometers, and I say inferred deliberately because those sizes depend entirely on an assumed reflectivity. Change the assumption about how shiny the object is and the size changes with it. The second category is called continental, and this is where the story gets its headlines. These are objects that appear to move across the lunar surface itself. Some of them are described as disc-shaped, and those are given as 25 to 40 kilometers in diameter, with brightness fluctuations of about 1% at several hertz. And then there are the toroids. Toroidal means ring-shaped, donut-shaped, a solid of revolution with a hole through the middle. The papers report toroidal objects roughly 36 kilometers across, moving at up to 11 kilometers per second, with a rotation period of about 180 seconds, 3 minutes per revolution. From that rotation period and that size, the authors calculate the centrifugal acceleration at the rim. They get roughly 2,200 centimeters per second squared, which works out to about 22 meters per second squared, which is about 2.2 times the surface gravity of Earth. That number is presented as one of the most striking findings in the whole series, because a rotating structure generating artificial gravity in the range of Earth's own gravity is exactly the engineering solution that human beings have been sketching for spacecraft habitats since the 1920s. It looks like design. It looks like somebody built it on purpose to be lived in. The companion papers extend the picture. There are related preprints titled UFOs on the Moon and Observations of Unidentified Flying Objects on the Moon and Anomalous Phenomena Near the Moon. Across those, the reported sizes range from 14 kilometers up to 40 kilometers, The speeds range from 6 to 20 kilometres per second. Brightness variability runs around 2% at several hertz, and reconstructed images show both disk and ring-shaped forms. One toroidal object in that set is given a rotation period of about 157 seconds and a centrifugal acceleration of 461 centimetres per second squared, which is about 4.6 metres per second squared, roughly half of Earth's surface gravity. Now I want to do a small piece of arithmetic on air, not to score a point, but because it is a good demonstration of the habit I am trying to hand you. If something rotates once every 180 seconds and produces 2,200 centimetres per second squared at its rim, you can work backwards to the radius, because centrifugal acceleration is just 4 times pi squared times the radius divided by the period squared. Run that and you get a radius of about 18 kilometres, which means a diameter of about 36 kilometres. So that number is internally consistent. Good. But run the same arithmetic on the other object. 157 seconds, 461 centimetres per second squared. That gives you a radius of about 2.9 kilometres, a diameter of under 6 kilometres, not 36. That is not a contradiction in the papers themselves, because those are simply 2 different objects with 2 different sizes. But it is absolutely a contradiction in a great deal of the coverage, which has been cheerfully collapsing every figure in the series into one enormous 36-kilometre machine spinning at Earth gravity. When you see 2 numbers quoted together that cannot both describe the same object, that is your first signal that the story has been through several hands and lost fidelity at each one. And then there is the camouflage claim, which I mentioned before, and which I want to state precisely now, because it is going to matter enormously. The papers describe these objects as heavily camouflaged, nearly identical to the moon in colour and brightness, with contrast typically no more than 10% against the lunar background. They are described as being almost invisible without high-cadence imaging and variability-sensitive processing. So the picture being painted is this. There are more than 20 objects. The largest are the size of a small country. They move at speeds that would carry them across the face of the moon in minutes. They spin fast enough to generate artificial gravity, and they are hiding in plain sight, matched so precisely to the lunar surface that you need specialized software to pull them out of the noise. Every single one of those numbers came out of a telescope, so the only sensible next question, the one I could not stop thinking about when I first read this, is a very simple one. What telescope? Part 3. The 6-inch telescope. The instrument is named in the observations. It is an Intes Micro Ultra M603, operated from a site south of Kyiv, recording through high-speed cameras. I looked it up, expecting to find some observatory-grade reflector with a name I would have to practice pronouncing. That is not what it is. The Intes Micro Ultra M603 is a 150mm Maksutov-Cassegrain telescope. 150mm is 6 inches. Its focal length is around 1500mm. It operates at f10. It weighs about 6 kilograms fully assembled, and the tube is roughly 385mm long. You could carry it under one arm. It was made by a Russian manufacturer, sold through amateur astronomy retailers, and it has an excellent reputation among hobbyists. People who own them speak about them with real affection. The optics are genuinely good for the aperture, the build quality is solid, and second-hand ones still command decent prices. I want to be completely fair here, because this is the point where a lot of coverage would sneer, and sneering is both unkind and unnecessary. This is a nice telescope. It is not a toy. It is also, unambiguously, a consumer instrument. It is the sort of thing an enthusiastic amateur buys because it is compact enough to travel with and sharp enough to show good planetary detail, and that creates a gap between 2 things that have been fused together in every headline about this story. The institution is professional, the National Academy of Sciences of Ukraine is a real national academy, and the Main Astronomical Observatory is a real observatory with real research output. But the optical train that produced the most extreme claims in this entire series is a 6-inch amateur Maksutov. Those are 2 different facts, and when they get welded into the phrase professional observatory instrumentation, something misleading has happened without anybody technically lying. Now let me walk through how a Maksutov actually works, because one specific feature of the design is going to come back later and detonate this entire story. and I would rather plant it now while it seemed like a dry technical aside. Light enters the front of the tube through a thick curved glass corrector plate. That plate is deeply dished, which is what gives the Maksutov its characteristic look and its ability to squeeze a long focal length into a short tube. The light passes through the corrector, travels down the tube, hits a spherical primary mirror at the back, and reflects forward again. Then it hits a secondary mirror and gets sent back down through a hole in the centre of the primary, out to your eyepiece or your camera. Here is the part to remember. In this design, the secondary mirror is typically an illuminized spot on the inside surface of the corrector plate itself. It sits directly in the middle of the light path, which means that in the centre of the incoming beam of light there is a circular obstruction. Every telescope of this general family has one. Schmidt-Cassegrains have one. Newtonian reflectors have one. It is the price you pay for folding a long optical path into a short tube, and under normal circumstances it costs you a small amount of contrast and nothing else. You never see it as a shape. Remember that sentence. Under normal circumstances you never see it as a shape. Now, resolution. A 6-inch aperture has a theoretical resolving limit of roughly 9/10 of an arcsecond. An arcsecond is 1/3600th of a degree, an absurdly small angle, and the fact that a telescope you can carry under your arm can distinguish detail that fine is a genuinely beautiful piece of physics. That 9/10 of an arcsecond is a hard ceiling set by the wave nature of light itself. No amount of processing gets you below it with that aperture, but that is the theoretical limit, achievable only if the air between you and the sky is perfectly still, which it never is. What actually limits you is seeing. The atmosphere is not a uniform slab of transparent gas. It is a churning stack of air pockets at slightly different temperatures, and therefore slightly different densities, and therefore slightly different refractive indices. Each pocket acts as a weak, wandering lens. Light from a point source arrives at your telescope having been bent slightly and randomly by dozens of those lenses on the way in, and the result is that a star does not appear as a point. It appears as a small, boiling blob that shifts and shimmers many times per second. From a mountaintop observatory site on an exceptional night, seeing might be half an arcsecond. From a lowland site in continental Europe, on an average night, seeing is typically somewhere between 2 and 4 arcseconds, frequently worse. This is not a criticism of anybody's location, it is simply where most of humanity lives. So write down that number and keep it somewhere accessible. 2 to 4 arcseconds. That is the size of the smallest thing this setup can honestly claim to distinguish. It is worth understanding what a 6-inch aperture buys you, and what it does not, because aperture governs 2 separate things and people constantly conflate them. The first is light gathering. The area of the objective determines how many photons you collect per second, which is what lets you see faint things, and a 6-inch collects roughly 450 times more light than a fully dark adapted human eye. That is a lot. The second is resolution, and resolution scales with the diameter, not the area, and it is the harder ceiling. Doubling your aperture to 12 inches halves the smallest angle you can separate. On the moon specifically, a 6-inch on a good night will show you craters down to a few kilometres across, the terracing on the inner walls of the big impact basins, and the central mountain peaks that rebounded upward in the moments after those basins formed. It will not show you the Apollo landing sites. It will not show you the descent stages or the rovers or the flags, because those are meters across and you would need an aperture measured in tens of meters to resolve them from here. That is the honest performance envelope of the instrument that produced these observations. There is one more piece of context about the equipment worth having, and it comes from the earlier phase of this research rather than the lunar phase. The atmospheric work that preceded the lunar papers was conducted using 2 meteor stations, fitted with colour video cameras, pointed at the daytime sky, at Kyiv and at a village called Vinarivka. Meteor stations are built for a specific job. They watch wide fields at night for fast-moving streaks, and they are optimized for detection and timing, not for photometric precision or careful distance work. And according to a formal statement issued later by the observatory's own scientific council, the footage in question was captured while those stations were running in test mode during scheduled meteor observations. It was not a dedicated, controlled survey designed to detect and characterize unknown objects. It was equipment doing one job, being read for evidence of another. That is a real and important distinction, and it is going to come up again when we get to what the observatory said about all of this. But we are not there yet. We are still on the number I asked you to write down, 2 to 4 arc seconds, the practical limit of what this instrument can separate on a normal night from a lowland site, because in about 4 minutes I'm going to convert the paper's own headline claims into arc seconds, and when those two sets of numbers sit next to each other, the entire story changes shape. Part 4. How big is 36 kilometres really? Here is the conversion that nobody in the coverage performed, and it is the single most useful thing in this entire video. The mean distance from the Earth to the Moon is 384,400 kilometres. That is a measured number, known to centimetre precision, thanks to lasers fired at retroreflectors sitting on the lunar surface. At that distance, 1 arc second of sky corresponds to 1.864 kilometres. That is the whole ruler. That one line. If you remember nothing else from this, remember that at the Moon, 1 arc second is about 1.9 kilometres, because it lets you check every future claim anybody ever makes about an object near the Moon, in your head, in about 4 seconds. Let me build it up so it is not just a number I asserted at you. A full circle is 360 degrees. Each degree splits into 60 arc minutes. Each arc minute splits into 60 arc seconds. So an arc second is 1/3600th of a degree, which is a very small angle indeed. The Moon itself, the whole visible disk, spans about half a degree, which is about 1800 arc seconds across. Hold your little finger up at arm's length and it comfortably covers the entire Moon. That is how small half a degree is, and the Moon is filling almost 2000 arcsecons of it. So, take the paper's numbers and put them through the ruler. 14 kilometres, the smallest object in the series, becomes 7.5 arcseconds. 25 kilometres becomes 13.4 arcseconds. 36 kilometres, the headline toroid, becomes 19.3 arcseconds. 40 kilometres, the largest disk, becomes 21.5 arcseconds. Those numbers mean nothing until you anchor them against something you have actually looked at through a telescope. So here are the anchors. Saturn's globe, the planet itself without the rings, subtends about 18 to 20 arcseconds as seen from Earth. Mars, at a good opposition when it is closest to us, and every astronomer on the planet is pointing at it, subtends about 24 to 25 arcseconds. Jupiter, the biggest planetary disk in our sky, subtends about 45 to 50 arcseconds. The International Space Station, at closest approach directly overhead, subtends about 60 arcseconds. Read that list again against the previous one. A claimed 36-kilometre object at the Moon would appear, in the eyepiece, at essentially the same angular size as the planet Saturn, not a point of light, not a faint smudge that needs software to extract. A disk, the same apparent size as the object that made you gasp the first time somebody let you look through their telescope at a star party. Larger than Saturn's globe if you take the 40-kilometre figure, approaching Mars at its best, and there is more than 20 of them. Now add the motion, because the motion is arguably even more absurd than the size. 11 kilometres per second at the Moon's distance works out to an angular rate of 5.9 arcseconds per second. So the object is moving very nearly a third of its own apparent width every second. It would cross the entire face of the Moon, all 1800 arcseconds of it, in a little over 5 minutes. That is not a subtle drift you would need time-lapse to detect. That is visible motion in real time, in the eyepiece, obvious to the naked eye at the telescope, the way you can watch the International Space Station move against the stars. I want to put this directly against the paper's own framing, because the two do not survive contact with each other. The paper says these objects are heavily camouflaged. It says their contrast against the lunar background is no more than about 10%. It says they are almost invisible without high-cadence imaging and variability-sensitive processing. A Saturn-sized disk crossing the face of the Moon in 5 minutes is not a marginal detection that requires specialized software to tease out of the noise. It is the most conspicuous thing that has ever happened in the field of view. And consider what we routinely resolve on the Moon with equipment in this class. A 6-inch telescope on a decent night, working at 2 to 4 arcseconds of seeing, resolves lunar features about 4 to 8 kilometres across. The crater Copernicus, which is 93 kilometres wide, is a trivial target for a beginner. Tycho, at 85 kilometres with its enormous ray system, is one of the first things anybody learns to find. The chain of craters along the Terminator, the wrinkle ridges in the Maria, the central peaks inside the big impact basins, all of that is standard amateur fare. An object 19 arcseconds across sitting on that surface is not at the edge of detectability. It is roughly 40% the width of the crater Copernicus, in apparent terms, and it is moving. There's a second way to feel the scale, and it works better for some people. Forget arcseconds for a moment, and think in fractions of the Moon itself. The Moon is 3,475 kilometres across. An object 36 kilometres wide is therefore about 1/100th of the lunar diameter. That sounds small until you actually draw it. Take a photograph of the full moon on your phone, and 1/100th of its width is a clearly visible dot, comfortably larger than the pixel grid, sitting there in the image. Now imagine 20 of them. Now imagine them moving fast enough that in a 30-second exposure they would draw visible streaks across the disk. And this is the point where the camouflage argument stops functioning as an explanation and starts functioning as a patch. Camouflage explains why something is hard to see. It does not explain why something the apparent size of Saturn, crossing the most heavily monitored object in the sky, was recorded by exactly one instrument. Matching the moon's colour and brightness to within 10% would make an object subtle. It would not make it absent from every other dataset on Earth. So the shape of this has changed, and I want to be precise about how. We are no longer in the territory of belief. We are not asking whether you personally find it plausible that an advanced civilization would station machinery at the moon. That is a matter of taste and imagination, and people can differ about it forever without either side learning anything. We are asking something much narrower and much more answerable. We are asking whether an object with the apparent size of a planet crossed the face of the most photographed object in the entire sky more than 20 times over 2 months and produced exactly one set of recordings from one 6-inch telescope in one place. That is a question with an answer, and the answer starts with the fact that on any given clear night there are tens of thousands of other people pointing cameras at the exact same target. Part 5. The Sky. Everybody is already watching. The moon is the most photographed object in the sky, and it is not close. It has held that title since photography existed. The first surviving photograph of the moon was made in 1840. There is a continuous unbroken chain of human beings pointing light-sensitive equipment at it, stretching from that daguerreotype to whatever somebody uploaded 20 minutes ago. And in the last 2 decades, that chain has widened into something without any precedent in the history of astronomy. Lunar imaging is the entry point into amateur astronomy for a very simple reason. The moon is forgiving. It is bright, so you do not need long exposures or expensive cooled sensors. It is close, so you do not need perfect tracking. It sits high enough in the sky from most latitudes to avoid the worst of the atmosphere, and it is completely immune to light pollution, which means you can do serious lunar work from the middle of a city where you could not see the Milky Way if your life depended on it. A teenager with a second-hand telescope and a phone adapter can produce lunar images that would have been publishable in a scientific journal in 1960. And the technique that community uses is precisely the technique described in these papers. High-cadence video, hundreds or thousands of frames captured in a burst, software sorting them by sharpness, the best few percent aligned and stacked. It is called lucky imaging, and it works because the atmosphere is not uniformly bad. It is intermittently, briefly good, and if you record fast enough you catch those moments. That method is not obscure, it is the default. There are free software packages for it downloaded by hundreds of thousands of people. So when I tell you that a 6-inch telescope is on the small end of what is out there, I want you to understand the scale of what is out there. 8-inch telescopes are the standard beginner recommendation. 10 and 12-inch instruments are common in suburban driveways. 16-inch and larger are unremarkable at any organised star party. There are amateur observatories with permanent piers and roll-off roofs in more countries than I can list, run by retired engineers and doctors and teachers, imaging the moon on every clear night because it is there and because it is beautiful. Now hold that against the claim. More than 20 objects, some of them the apparent size of Saturn, moving fast enough to cross the lunar disk in 5 minutes, present across 2 full months of observation. The statistical problem is not that nobody else could have seen them. The statistical problem is that they would have been recorded independently, repeatedly, by people scattered across every continent and every time zone, who do not know each other, who have no shared incentive, who are frequently in open competition with each other for the best image of the month, and who would have absolutely nothing to gain and everything to win by being the second person to confirm the largest discovery in the history of astronomy. We know what that looks like when it happens, because it does happen. When a bright fireball crosses a populated area, the internet fills with dashcam and doorbell footage within the hour. When a genuinely unusual lunar event occurs, independent captures appear from multiple countries before the professionals have finished writing their first email. The amateur network is fast, it is enormous, and it is chronically underestimated by people who have never interacted with it. And it does real science, which is the part people tend not to know. Lunar occultation timing, which is the practice of recording the exact instant a star disappears behind the moon's limb, is almost entirely amateur-driven, and it has been used to measure the diameters of stars, to discover close binary systems that no telescope can separate directly, and to refine the shape of the lunar limb itself. Amateurs have detected impact flashes on the moon, and had those detections confirmed by professional programs. During the total lunar eclipse of January 2019, a meteoroid struck the moon while it was in Earth's shadow, and the flash was captured independently by multiple observers scattered across Europe and the Americas, because that is what happens when thousands of people happen to be pointing cameras at the same target on the same night. That single event, lasting a fraction of a second, produced more independent confirmations than these papers have produced in 2 months of claimed observations of objects the apparent size of Saturn. I keep coming back to that comparison because it frames the whole problem cleanly. A flash lasting less than a second, from an impact by a rock about the size of a football, was caught by many independent observers on several continents. More than 20 objects, some of them the apparent size of a planet moving visibly across the lunar disk over 2 months, were caught by one. Nothing like that happened here. No other observatory, professional or amateur, has reported detecting structured objects of kilometre scale near the moon. There is no independent replication of any kind, and I want to be careful about how I use that fact, because absence of evidence is a phrase that gets thrown around badly in both directions. In general, the fact that nobody else has seen something is weak evidence. It only becomes strong evidence when the thing in question would be trivially easy for other people to see, and when a very large number of people are already looking in exactly the right place with exactly the right equipment. Both of those conditions are satisfied here, about as completely as they can ever be satisfied. This is not a faint signal at the edge of detection in a poorly surveyed part of the sky. This is a planet-sized apparent disk on the single most surveyed object in the sky. There is a fair objection to make, and I want to make it myself rather than let it sit unspoken. Somebody could reasonably say that other imagers would not have detected these objects because they were not running the specific variability-sensitive processing needed to pull out a 10% contrast feature. That is a real argument. But it collapses on the size. At 19 arc seconds, moving at 6 arc seconds per second, you do not need clever processing. You need to be looking at the screen. Live view on a modern planetary camera updates many times per second, and every lunar imager watches it while they focus. So the wide net came up empty, but the wide net is not the only thing watching, because there is something else that has been observing the moon continuously from about 50 kilometres away without a single break since 2009. Part 6. The Orbiter in the Way. The Lunar Reconnaissance Orbiter has been in orbit around the moon since June of 2009. It has not stopped. It has been circling continuously for well over 15 years, which makes it one of the longest-running planetary missions in history, and in that time it has essentially rewritten the lunar map. Its primary camera system images the surface at resolutions down to about 0.5 meter per pixel, which means individual boulders, individual small craters, and the actual hardware left behind by the Apollo missions. You can see the descent stages. You can see the tracks the astronauts left walking between them, still there, because there is no wind and no rain and nothing to erase them. Its working altitude has varied across the mission, but has generally sat between about 50 and 200 kilometres above the surface. Now put those two facts next to each other. Objects are claimed to be operating against the lunar surface at sizes between 25 and 40 kilometres, moving at up to 11 kilometres per second. And there is a spacecraft flying through that exact volume of space, continuously, for 15 years, photographing everything beneath it at 0.5 meter resolution. There is no version of this where the objects are hiding from the orbiter. A 36-kilometre structure in low lunar orbit is not a subtle presence. It is a body large enough that the orbiter would have to navigate around it. It would perturb the orbiter's own trajectory gravitationally, and the orbiter's trajectory is tracked to a precision that lets scientists map the Moon's internal mass distribution from the wobbles. Let me give you a sense of what 36 kilometres actually is as a physical object. It is longer than the island of Manhattan by a factor of 2.5. It is roughly the width of the English Channel at its narrowest point. If you set it down on the ground, it would span from one side of a major metropolitan area to the other, and it would take you most of a day to walk its length. We are being asked to accept more than 20 objects in that class, operating in a shell of space that we have been instrumenting continuously since before the first iPhone. It is worth knowing how fine-grained that orbiter's record actually is, because the examples are genuinely impressive. When India's Vikram lander crashed on the lunar surface in 2019, the debris field was located in the orbiter's images by an amateur analyst working from publicly released data, picking out scattered fragments a few pixels across against a field of grey dust. When a mystery rocket stage struck the Moon in 2022, the orbiter went and photographed the result, and found not one crater, but 2 overlapping ones side by side, which is a signature that told investigators something about the mass distribution of whatever hit. And on a much larger scale, the orbiter's own orbital wobbles tracked from Earth have been used together with dedicated gravity mapping missions to model the density structure of the lunar interior, including buried mass concentrations under the ancient impact basins. That is the sensitivity of the instrument in question. It finds crashed hardware a few meters across. It counts craters that were not there last year. Its own trajectory is being read as a probe of what lies beneath the surface, and it has been doing that continuously in the exact volume of space where 25 to 40 kilometre structures are claimed to operate. And this is not a single agency's dataset, which matters, because the reflexive response to any claim like this is that a space agency might have reasons to stay quiet. Over the same period, the Moon has been orbited by spacecraft from the United States, the European Space Agency, Japan, India, China and South Korea. Those are not organisations with aligned interests. Several of them are in active strategic competition with each other. The idea that all of them independently observed and concealed the same thing requires a level of coordination that those same organisations demonstrably cannot achieve on far easier problems. I have talked on this channel recently about how precisely we now watch the lunar surface, and it is worth pulling that thread forward here. In the video from August 3rd, we went through the modelling of what happens when an artificial object hits the Moon, right down to the maximum ballistic range of the ejected material, which comes out at slightly under 1,000 kilometres. We are now at the point where a rocket stage striking the Moon can be predicted to the half-second and the individual crater, and where the resulting debris curtain can be modelled well enough to argue about whether it constitutes a hazard to future infrastructure. That is the resolution at which we now observe that surface, which is exactly why nothing at the scale being claimed can be sitting on it unremarked. Now, I want to hand you the strongest version of the counter-argument, because there is a real and legitimate gap in our lunar surveillance, and I have talked about it at length. We are genuinely bad at tracking things in cislunar space. Radar returns fall off with the 4th power of distance, which makes the volume between the Earth and the Moon effectively a blind zone for the systems we use to track objects in Earth orbit. There are derelict rocket stages out there right now that nobody is formally responsible for watching, and we have had cases where an object was identified only after somebody with a personal telescope and a spreadsheet worked out what it was. All of that is true, and none of it helps here. Being poor at tracking a 4,000 kilograms spent rocket body that is a few meters across, tumbling somewhere in 100,000 kilometers of empty space, is a completely different problem from being blind to a 36-kilometer structure sitting against the illuminated face of the Moon. I make that distinction carefully because I do not want anybody to walk away from this overcorrecting in either direction. Real gaps in our awareness exist. This claim does not sit inside one of them. So the objects are not in anyone else's images, and they are not in the orbiter's data, and they would have to be enormous to look the way they are described. Which brings us back to the recordings themselves, because something is in those frames, and the question is what the atmosphere does to a video signal in the exact regime this equipment was operating in. Part 7. What a blurred sky actually does. 2 to 4 arc seconds. That was the number I asked you to hold on to, and this is where it comes due. That is the practical seeing limit for a 6-inch instrument at a lowland site on a typical night. It is the size of the smallest thing that can be honestly distinguished, because it is the size of the blur that the atmosphere paints over everything. The objects being claimed run from 7.5 arc seconds up to 21.5, so the claimed objects are between about 2 and about 7 times larger than the atmospheric blur cell itself. That sounds like a comfortable margin, and in a different context it would be. But this is precisely the regime where structure and artifact become hardest to separate, because everything you see at that scale has been smeared, shifted and modulated by the same turbulence, and the software you use to fix that introduces its own signatures on top. Let me walk through what the atmosphere actually does to a light signal, because this is the mechanism that explains most of what these papers describe as evidence of technology. Start with scintillation. That is the technical name for twinkling. A star twinkles because those wandering pockets of warm and cool air act as weak lenses, and as they drift across your line of sight, they alternately focus and defocus the incoming beam. The brightness at your sensor goes up and down. That is not a property of the star. It is a property of the air. Now here is the part that matters. Scintillation is not random noise smeared evenly across all frequencies. It has characteristic timescales, set by how fast the turbulent cells move across your aperture, driven by high-altitude wind speeds. For a small aperture on a normal night, the dominant scintillation frequencies land in the range of a few hertz to a few tens of hertz. A few hertz. The papers report a fundamental frequency with harmonics, clustered in the range of a few hertz, and present the structured periodicity as a signature of technology. But a few hertz is the frequency band the atmosphere writes into every single high-cadence recording ever made from the ground. It is not a signal that emerged from the object. It is, at minimum, a signal that cannot be distinguished from what the sky does to everything. And scintillation is only the first contaminant on the list. There are several others that live in the same neighbourhood. Video sensors introduce their own periodicities. Rolling shutter readout, where the sensor is scanned line by line rather than captured all at once, produces artifacts on fast-moving objects that vary systematically with the object's speed across the frame. Frame rate beating against other periodic sources produces false rhythms. Artificial lighting in Europe runs at 50 Hz, and any scattered light from that source will beat against your capture rate to produce difference frequencies that can land anywhere from a fraction of a hertz upward, depending on your settings. Mounts introduce periodicities too. Every tracking mount has periodic error, a small oscillation in the drivetrain that repeats with the worm gear period. Autoguiders correcting for it can overshoot and oscillate. Focus drifts as the tube cools, and a slowly changing focus changes the apparent size and brightness of everything in the frame. And then there is the processing, which is where I think the most interesting failure lives. Stacking software works by registration. It picks features in each frame, works out how the frame is shifted relative to a reference, and moves it back into alignment before combining. On the Moon, it locks onto lunar surface features, because those are the sharpest, highest contrast things available. Think carefully about what that does to anything in the frame that is not moving with the Moon. The software is actively transforming every frame to hold the lunar surface still. Anything that was genuinely stationary relative to the ground now acquires artificial motion in the stack, because the Moon's own motion across the sky has been mathematically subtracted and dumped onto everything else. The papers explicitly mention that objects appear to travel across the lunar disk after frame. Alignment removes lunar motion and tracking errors. That sentence is describing the exact operation that manufactures apparent motion in foreground objects. Stacking also produces structure in unexpected places. When you combine thousands of frames with outlier rejection, the rejection map itself, the record of which pixels were discarded from which frames, contains coherent shapes. Anything that crossed the field during the capture leaves a trace in that map. Reconstruct an image from data that has been through that pipeline, and you can recover shapes that were never a single coherent object in any single frame. There is one more contaminant worth naming, and it is the one that will matter most in a few minutes, so I am going to introduce it gently here and let it sit. A telescope has a depth of field, the same way a camera lens does, and for a long focal length instrument focused on an object nearly 400,000 kilometres away, that depth of field is effectively infinite in one direction and brutally shallow in the other. Anything closer than a few kilometres is not slightly soft. It is catastrophically out of focus, spread across a large area of the sensor and rendered at very low contrast against whatever is behind it. Low contrast, spread out, structured in a way that has nothing to do with the object's actual shape. Those are the properties of a near-field object seen through an instrument focused at infinity, and they are also, word for word, the properties these papers attribute to camouflage technology. Which brings me to the low contrast figure, and why I keep returning to it. The papers report these objects at 10% contrast or less against the lunar background, and they present that faintness as evidence of deliberate camouflage. But 10% contrast is exactly where artifact and signal are least separable. It is the regime where you cannot tell the difference between a real thing that is faint and a processing residue that is not a thing at all, and an interpretation that converts weak signal into strong proof by explaining the weakness as intentional concealment is doing something that should always make you uneasy. It is a claim that becomes more convincing the worse the data gets. None of this proves the frames are empty. I want to say that plainly because I am not in the business of overselling in the opposite direction. What it establishes is that every distinctive property reported in these papers, the flashes, the few hertz modulation with harmonics, the apparent motion, the low contrast, the reconstructed structure, is a property that a blurred sky and a stacking pipeline will hand you for free. But all of that still leaves the largest hole in the entire argument completely untouched. Because underneath every size, every speed, and every acceleration in this series of papers, there is one number that was never measured at all. Part 8. The one number nobody measured. A telescope measures angles. That is what it does. That is all it does. It takes light arriving from different directions and separates it, and what you get out the other end is a map of how bright the sky is as a function of direction. Angles in, angles out. A telescope does not measure distance. It cannot. There is nothing in a single image, from a single location, at a single moment, that tells you how far away anything is. I want to make that concrete, because it sounds abstract until you have felt it. Hold your thumb up at arm's length and it covers the moon. Your thumb is about 2 centimetres wide and about 70 centimetres away. The moon is 3,500 kilometres wide and 384,000 kilometres away. They subtend the same angle. In terms of pure angular measurement, in that instant they are indistinguishable. Every photograph you have ever seen where somebody appears to be holding up the Leaning Tower of Pisa works on exactly this principle. Angular size does not encode distance, so write the relationship out because it is the entire story in one line. Physical size equals angular size multiplied by distance. Physical speed equals angular rate multiplied by distance. Distance is a multiplier sitting on the front of every quantity you care about. If you get it wrong by a factor of 10, every size and every speed you derive is wrong by a factor of 10. If you get it wrong by a factor of 1,000, everything is wrong by a factor of 1,000, which means that 36 kilometres is not a measurement. 11 kilometres per second is not a measurement. 2,200 centimetres per second squared is not a measurement. Every one of those figures is an angular measurement multiplied by an assumption about how far away the object was. They are assumptions wearing measurements clothes. So how do astronomers actually determine distance, when the image alone cannot tell them? The oldest and most reliable answer is parallax. Parallax is the effect you get by looking at the same thing from two different places. Hold your finger up and close one eye, then the other, and the finger jumps against the background. The closer the finger, the bigger the jump. Measure the size of that jump, know the separation between your two viewpoints, and trigonometry hands you the range. That is how surveyors have worked for centuries, and it is how we measured the distance to the nearest stars, using the diameter of Earth's orbit as the baseline. To do it, you need 3 things without exception. 2 observers with a known separation, the same object recorded from both, and the recordings taken at the same instant. The earlier atmospheric work had 2 stations, at Kyiv and at Vinarivka village. That is the correct architecture. That is exactly what you would build if you wanted to do this properly. But when the observatory's own scientific council formally reviewed that work, one of the specific deficiencies they identified was that the paper did not indicate which events had been observed simultaneously from both stations. They also noted the absence of the observation dates entirely. Sit with what that means. Having two stations is not a distance measurement. Having two stations and knowing which events were captured at both at the same moment and by how much the apparent position differed is a distance measurement. Without that last piece, the second station is just a second camera. Parallax is not a fussy technicality. It is the foundation of every distance in astronomy, and the entire cosmic distance ladder is built on it. In 1838, Friedrich Bessel measured the parallax of the star 61 Cygni and produced the first reliable distance to a star other than the Sun, and the shift he had to detect was about a third of an arcsecond over 6 months. That measurement is why we know the universe is big. Everything above it on the ladder, the standard candles, the supernovae, the expansion rate, is calibrated against parallax at the bottom. The European Gaia spacecraft has now done it for well over 1 billion stars. The reason I labour this is that parallax is not hard to do for something close. The closer an object is, the bigger the shift, which means near-field objects are the easy case. 2 cameras a few kilometres apart recording the same instant would separate a bird at 1 kilometre from a structure at the moon so decisively that there would be nothing left to argue about. The bird would jump enormously between the two views. The lunar object would not move at all. It is the cleanest possible experiment. It requires equipment that both stations already had, and it is exactly the measurement that was not demonstrated. So what was used instead? The papers describe a colorimetric method. The idea is to estimate distance from the object's colour and its contrast against the sky, on the reasoning that the atmosphere between you and the object scatters light in a way that depends on path length. So a more distant object will be shifted and washed out in a predictable way. That is a legitimate physical effect. It is why distant mountains look blue and pale. But using it to get a distance requires you to know what the object's intrinsic colour and reflectivity were before the atmosphere modified them, and that is the unknown. The reflectivity of an unidentified object is precisely the thing you do not have. So watch the circle close. You assume a reflectivity in order to derive a distance. You use that distance to derive a physical size, and then you cite the physical size, 36 kilometres, as evidence about what kind of object it is, and therefore what its reflectivity would plausibly be. The conclusion is standing on the assumption, and the assumption is being justified by the conclusion. That is the structural failure at the base of every number in this story, and it is the same failure at the moon that it was in the troposphere. The only thing that changed between the two sets of papers is which distance got assumed. There is also, and this is not a small thing, no error analysis. There are no confidence intervals on the load-bearing quantities. There is no artifact analysis. For a claim of this magnitude, the absence of an uncertainty budget is not a stylistic omission. Uncertainty is how a scientist tells you how much to trust a number, and a number handed over without one is a number the author has not tested against their own doubts. And I should say something about the word preprint, because it is doing a lot of quiet work in the way this story has been shared. A preprint is a manuscript that has been made public before, or instead of formal review. Posting to Archive involves a moderation step that checks whether a submission is topically appropriate and not obvious nonsense. It does not involve anyone checking whether the physics is right. A digital object identifier issued by a repository like ResearchGate is generated automatically on upload. It looks exactly like a journal identifier, and it certifies nothing. I am not saying that to be dismissive. Preprints are genuinely valuable, and enormous amounts of excellent physics appear as preprints first, but a preprint is a claim in public, not a claim that has been checked, and the difference matters most precisely when the claim is extraordinary. So we have arrived at the real question. If the distance assumption is what is holding all of this up, and the distance was never actually measured, then what happens if we simply change it? The answer is one of the most satisfying pieces of arithmetic I have run in a long time, and it turns 36 kilometres into something you could hold in your hand. Part 9, 9 centimetres, at 1 kilometre. Let me do the substitution, and I want to be scrupulous about the rules of the exercise. I am going to keep every single angular measurement in these papers exactly as published. I am not going to argue that the software mismeasured anything. I am not going to claim the frames were misread. 19.3 arc seconds of apparent width, 5.9 arc seconds per second of apparent motion, Those stay fixed. The only thing I'm going to change is the assumed distance. Instead of 384,000 kilometres, let us say the object was 1 kilometre away. 19.3 arc-seconds at 1 kilometre is an object approximately 9 centimetres across. 5.9 arc-seconds per second at 1 kilometre is a speed of approximately 29 metres per second. That is about 65 miles an hour. 9 centimetres, 65 miles an hour. That is a bird, not metaphorically. That is the size and the speed of a bird. A swift in level flight cruises comfortably in that range. A pigeon in a hurry does that. A duck absolutely does that. 9 centimetres is the body width of any number of common birds once you account for a blurred, defocused silhouette spreading wider than the animal actually is. Run it again, closer. At 100 metres, the same angular measurements give an object well under a centimetre across, moving at a couple of metres per second. That is an insect, a moth crossing the aperture at walking pace. And I want to emphasise what just happened, because it is the entire point of this video compressed into 30 seconds. Nothing was fudged. No number was disputed. The exact same measurements, taken from the exact same frames, describe either a 36-kilometre engineered structure moving at 4.5 times lunar escape velocity, or a bird. The only difference between those two conclusions is a single assumption that nobody verified. Now, I do not want you to take my word that birds and insects crossing the lunar disk is a real phenomenon rather than a convenient skeptical invention. So let me be specific about how common it actually is. It is common enough to be a recognised genre in amateur astrophotography. Photographers who image the moon regularly accumulate these captures, the way wildlife photographers accumulate blurred rabbits. There are dedicated forum threads for them. There are people who have deliberately hunted them, timing bird migration corridors against lunar transits to get a clean silhouette shot on purpose. The technique of counting migrating birds by watching them pass in front of the moon is genuinely old, and ornithologists were doing systematic moon-watching counts of nocturnal migrants back in the 1950s, precisely because a bird crossing the illuminated lunar disk is a reliably detectable event through a modest telescope. Think about what that means. There is a body of scientific literature, decades old, built entirely on the fact that birds regularly and detectably fly across the face of the moon as seen from the ground. So what do they look like on film? They look dark because they are silhouetted against a bright background, and there is no illumination on the side facing you. They have sharp apparent edges when they happen to be in reasonable focus and very soft ones when they are not. They cross the field in a fraction of a second to a few seconds, depending on range and speed, and crucially, they modulate in brightness, rapidly, as wings beat and the body rocks, and the amount of sky they occlude changes with each stroke. Now hold that against the paper's own descriptions. Dark objects, low contrast, traversing the lunar disk in seconds, rapid periodic brightness variation with a fundamental and harmonics. Consider the flash duration specifically. The atmospheric class is reported as flashing for 100 to 500 milliseconds. A wing beat cycle for a medium-sized bird sits between roughly 5 and 15 beats per second, which puts a single beat somewhere between about 70 and 200 milliseconds. For a large bird, it is slower. For an insect, it is far faster, which is where you get into the higher frequency end of the range. I'm not going to tell you that every reported object is a specific species of bird, because I do not know that and neither does anybody else. What I'm telling you is that the reported properties do not require an exotic explanation. They are the ordinary, well-documented signature of small things flying close to the telescope. There is a useful way to think about the whole family of candidates, and it is worth walking through because it shows how little room the angular numbers actually leave. An apparent motion of about 6 arc-seconds per second is the fixed quantity. At the moon, that means 11 kilometres per second. At the distance of a passing satellite in low Earth orbit, 400 kilometres up, it would mean something moving at around 12 metres per second, which is far too slow for orbit and rules satellites out immediately. At the cruising altitude of an airliner 10 kilometres away, it would mean about 300 metres per second, which is almost exactly airliner cruise speed, and airliner transits of the moon are photographed constantly and look precisely like what they are. At 1 kilometre, it is bird speed. At 100 metres, it is insect speed. So the angular rate alone maps out a narrow corridor of possibilities, and every one of them except the lunar interpretation is something ordinary that we already know flies through that airspace in large numbers. The lunar interpretation is the only entry on that list that requires anything new to exist, and there is a second consistency check available in the flash statistics themselves. The papers report more than 20 objects over roughly 2 months of observation. That rate, a handful of detections per week of clear observing, is not what you would expect from a fleet of enormous machines conducting operations. It is very close to what you would expect from the rate at which birds, bats and insects cross a small field of view aimed at a bright object in a temperate European sky in late summer and early autumn. August and September in Ukraine sit in the middle of the autumn migration season, when nocturnal migrant traffic over the region is at its annual peak, and insect activity on warm evenings is still high. I'm not going to overclaim on that because I do not have the raw frames and I cannot do the identification. But when the observation window coincides with the single busiest period of the year for exactly the class of near-field objects that would produce this signal, that is worth saying out loud. Mick West, who has spent years doing frame-by-frame analysis of this kind of footage, made a very specific argument about the 2022 Kyiv images that is worth understanding, because it is a nice piece of reasoning. He looked at the positions of an object across successive frames and noticed that the spacing was uneven. The gap between the first and second positions was noticeably larger than the gap between the second and third. Uneven spacing across equal time intervals means acceleration. The object was changing speed rapidly within a fraction of a second. That single observation does a lot of work. An artillery shell or any other ballistic object does not change speed rapidly, because once it is in flight, the only things acting on it are gravity and drag, and neither produces sharp velocity changes over a few frames. A living thing flapping its wings changes speed constantly. So the kinematics themselves, read directly off the images, point towards something alive and near, not something fast and far. And yet, even granting all of that, there is one feature of these claims that birds do not explain, and I have been deliberately holding it back. Birds are not rings. The single strangest, most specific, most genuinely arresting thing in this entire paper series is the toroids, ring-shaped objects, donuts, 36 kilometres across, described as the showstopper of the whole investigation. And if all we had was a story about insects and pigeons, the rings would remain a loose end large enough to hang the entire claim on. They are not a loose end. They are the single most explainable thing in the entire story, and the explanation is sitting inside the telescope that recorded them. Part 10. The ring was the telescope. Ask the question that the coverage never asked. What makes a ring? Not what kind of civilization builds a ring, what optical circumstance produces a ring-shaped image. Go back to the instrument. The Intes Micro Alta M603 is a Maksutov Cassegrain, and I walked you through its layout earlier and then asked you to remember one specific feature. Here is where it comes due. In that design, light enters through a curved corrector plate at the front, travels to a spherical primary mirror at the back, reflects forward to a secondary mirror, and then passes back through a hole in the center of the primary to reach the sensor. And in a Maksutov, that secondary is usually an illuminized circular spot on the inner face of the corrector plate, sitting directly in the middle of the incoming light path. So there is a circular obstruction in the center of the beam. Every Cassegrain has one. Every Newtonian has a diagonal mirror doing the same job. It is intrinsic to the design. Now think about what the light is actually doing inside the tube. After the primary mirror, the light is a converging cone, narrowing toward a point at the focal plane. The obstruction removes the central portion of that cone. So the beam is not a solid cone, it is a hollow one, a cone with its core drilled out. When you are perfectly focused, that hollow core does not matter, because at the focal point the entire cone has converged, and there is nothing left to be hollow. The obstruction costs you a small amount of image contrast, and you never see it as a shape. But if you intercept that beam before it converges, the hollow is still there, and what you get on the sensor is a disk of light with a hole in the middle, an annulus, a ring. That is the entire explanation. A telescope with a central obstruction, imaging an object that is out of focus, produces a ring-shaped image. Not sometimes, not under special circumstances, by design, every time, as a direct and unavoidable consequence of the optical layout. I want to be emphatic that this is not an obscure claim requiring you to trust me. It is one of the first things anybody learns when they start using a telescope seriously, because it is the basis of the standard star test. Point at a bright star, rack the focus out, and watch the point of light expand into a donut. Every amateur astronomer alive has done this hundreds of times, because the concentricity and evenness of that donut is how you check whether your optics are aligned. If the hole is off-center, your collimation is off. There are entire chapters of telescope manuals devoted to interpreting the shape of that ring. If you own a telescope with a central obstruction, you can verify everything I just said tonight in about 90 seconds on any star you like. There is a detail about the star test that makes this even more pointed. The size of the donut depends on how far out of focus you are, and the relative size of the hole depends on the size of the central obstruction compared to the aperture. For a Maksutov Cassegrain, that obstruction typically covers somewhere between 1/4 and 1/3 of the aperture diameter. So the ring you get is not a thin circle. It is a thick annulus with a hole covering roughly 1/10 of its area, which is to say a fat, substantial donut. Exactly the geometry that would read as a solid ring-shaped body if you did not know what you were looking at. And the amount of defocus tells you how far away the object is. An object at infinity produces a point. An object at a kilometre produces a small donut. An object at 100 metres produces a large one. The angular size of the defocus blur, for an object well inside the focus distance, is set almost entirely by the geometry of the light cone rather than by the object's actual dimensions, which means that when the papers report objects ranging from 7 arcseconds to 21 arcseconds of apparent size, they may not be measuring a range of object sizes at all. They may be measuring a range of distances. That is worth stating in one clean sentence, because it is the deepest version of the point. If the apparent sizes are defocus blurs, then the size distribution in the papers is a distance distribution, and the objects could all be roughly the same physical size while appearing to span a factor of 3 in scale. Now connect the two halves. A near-field object, a bird or an insect at somewhere between 100 metres and a couple of kilometres, is not slightly out of focus in an instrument focused on the moon. It is wildly, hopelessly out of focus, because that instrument's depth of field at 1500 millimetres of focal length, focused at infinity, does not extend anywhere near that close. Which means a near-field object photographed by this telescope will not appear as a bird-shaped silhouette at all. It will appear as an annulus, a ring-shaped patch of reduced brightness, spread across a substantial area of the sensor at low contrast against the background. Every reported property lines up. The ring shape comes from the central obstruction. The large apparent size comes from the defocus spreading the object across the frame. The low contrast comes from that same spreading, diluting the occlusion across many pixels, and the apparent internal structure comes from the fact that the object is not a symmetric point source, but an irregular, tumbling, flapping thing, which modulates different parts of the annulus differently from frame to frame. The rotation figure comes out of the same place. If an irregular object crosses the aperture while beating its wings or tumbling, the brightness asymmetry around that ring will shift in a way that has periodic structure. Software analyzing that sequence, looking for rotation, will find a period. It has to find a period because there is a periodicity there. It just belongs to the wing beat, not to a rotating structure. And then the final step, the one that produces the most dramatic number in the entire story. Take that period, 180 seconds or 157 seconds or whatever the analysis returns. Combine it with a radius, compute the centrifugal acceleration, announce artificial gravity at twice Earth normal. But the radius came from the angular size multiplied by the assumed distance. Change the distance from 384,000 kilometres to 1 kilometre, and the radius drops by a factor of nearly 400,000, and the centrifugal acceleration drops with it, straight down into nothing. The artificial gravity does not survive the distance correction, neither does the size, neither does the velocity, neither does the base. So here is where we stand at the midpoint of this. Every distinctive feature of the claim now has an ordinary origin. The sizes and speeds come from an unverified distance assumption. The flashes and the few hertz modulation come from the atmosphere and from wing beats. The apparent motion across the lunar surface comes from stacking software that mathematically removes the moon's motion and dumps it onto everything else. The low contrast comes from defocus, and the rings, the showstopper, the thing that made this story travel, come from a mirror in the middle of the telescope. Now, if that were all I had, I would still be uneasy presenting it, because it is a reconstruction. It is me arguing that a set of things could have produced this result. which is not the same as demonstrating that they did, except that this exact error, made by this exact team, with this exact methodology, has already been caught once, in public, in a matter of hours, by a Harvard professor who wanted the objects to be real. Part 11. This already happened once. Go back 4 years, to August of 2022. A preprint appeared on a CHIF titled Unidentified Aerial Phenomena 1, Observations of Events. The authors were Boris Zhilyaev, Vladimir Petukov, and Volodymyr Reshetnik of the Main Astronomical Observatory of the National Academy of Sciences of Ukraine. The setup was the one I described earlier. 2 meteor stations at Kyiv and at Vinarivka village, fitted with colour video cameras, observing the daytime sky. A special technique developed in-house for detecting and evaluating the characteristics of unidentified objects. The paper reported 2 classes, and the naming convention is genuinely charming even if the physics is not. The first were called cosmics. Those were luminous objects brighter than the sky background. The second were called phantoms. Those were dark objects, showing contrast from a few percent up to about 50% against the sky. The phantom characterization is the interesting one. The paper described them as showing the color characteristics of an object with 0 albedo, a completely black body, in the paper's own words, that does not emit and absorbs all radiation falling on it, visible only because it blocks the Rayleigh scattered light of the sky behind it. From that framing, using the colorimetric method, the authors derived their numbers. Phantoms were placed in the troposphere at distances of up to 10 to 12 kilometres. Sizes were estimated at 3 to 12 metres. Speeds were given as up to 15 kilometres per second. Stop on that last figure, because it is genuinely extraordinary, and it deserves to be recognised as such rather than skated over. 15 kilometres per second is about 33,000 miles an hour in the lower atmosphere. That is roughly 44 times the speed of sound at sea level. Nothing human-made moves that fast inside air. The fastest air-breathing aircraft ever flown managed about 3 times the speed of sound. Re-entering spacecraft hit those velocities in the upper atmosphere, where the air is thin, and they arrive wrapped in plasma and shedding ablative heat shielding to survive it. So the claim was not modest. Objects the size of a bus, moving at 44 times the speed of sound, at low altitude, over a European capital, in broad daylight, and appearing completely black. The luminous class, the cosmics, is worth a moment as well, because it illustrates how the same method fails in the opposite direction. Those were reported as bright objects, some showing regular brightness variability in the range of 10 to 20 Hz, observed as singles, in groups, and in what the paper described as squadrons, moving at angular rates of 3 to 15 degrees per second across the sky. 3 to 15 degrees per second is fast. For comparison, the Moon is half a degree wide, so an object at 15 degrees per second crosses 30 lunar diameters every second. Very few things in the sky do that. Near-field objects do it constantly, because angular rate is inversely proportional to distance, and a bee at 10 meters can trivially cross 15 degrees in a second, while moving at a couple of meters per second. 10 to 20 Hz of regular brightness variation, meanwhile, is squarely in the wingbeat frequency range for a wide variety of insects. Honeybees beat their wings a couple of 100 times a second, which is far too fast, but larger insects, dragonflies and beetles and moths sit much lower, and many land in exactly that 10 to 20 band. Sunlit wings flickering at that rate against a bright sky produce precisely the kind of regular, harmonically structured light curve the papers report. So both classes, the dark and the bright, have the same signature problem. Their extraordinary properties emerge only after an unverified distance is applied, and their raw observable properties are consistent with small things moving close to the camera. The methodological fingerprint is identical to what we have just spent an hour taking apart on the lunar papers, angular measurements from video. An assumed distance derived colorimetrically rather than by parallax. Physical sizes and speeds calculated by multiplying the angles by that assumed distance. No demonstrated simultaneity between the two stations. No error analysis on the load-bearing quantities. And an interpretation that leaps directly from unexplained to technological. There is one more contextual detail that has to be stated, because it is not incidental. This was Ukraine in 2022. There was a full-scale war underway, and the sky over the country contained an extraordinary density of human-made hardware, much of it fast, much of it small, much of it moving in ways that nothing in peacetime aviation moves. A.V. Loeb made exactly that observation when he was first asked to look at the paper, and his phrasing was blunt. In science, he wrote, we aim to maximize the signal-to-noise ratio, and so Ukraine would be the last place on Earth where he would initiate a study of unidentified aerial phenomena. That is not a dismissal of the researchers. It is a statement about experimental design. If you are trying to identify unknown objects in the sky, you do not run the experiment in the environment with the most unidentified known objects in it. Which brings us to Loeb himself, and to the reason this particular episode is the key to the entire lunar story. Because the check that got run on that 2022 paper was not run by a skeptic looking to embarrass anyone. It was run by the single most prominent scientist in the world arguing that we should be taking the search for alien technology seriously, and he took it apart in an afternoon with a calculation you could do on the back of a napkin. Part 12. 1.5 terawatts. Avi Loeb is the Baird Professor of Science at Harvard University. He founded and directs the Black Hole Initiative there. He chaired Harvard's astronomy department for the better part of a decade. He heads the Galileo Project, which exists specifically to search for physical evidence of extraterrestrial technology using scientific instrumentation, and he has spent years arguing, publicly and at some professional cost, that the scientific community should treat that search as legitimate. I want that to land properly before I give you his argument, because it changes what the argument means. This is not a debunking by somebody who finds the whole subject embarrassing. This is a refutation by the field's loudest advocate for looking. He wrote later that over 2 weeks he had been bombarded with a dozen requests to read the Ukrainian report and had put it off. Then a request came from a senior official in the United States government, and he sat down with it the following morning and produced a paper within hours. Here is what he did step by step, because the reasoning is clean enough to follow without any physics background. Anything moving through air faster than sound compresses the air ahead of it into a shock front. That compression converts the object's kinetic energy into heat, and above a certain speed, into light. This is not a special effect. It is why meteors glow. A pebble entering the atmosphere at tens of kilometres per second becomes visible from hundreds of kilometres away, not because it is hot from friction in the way people usually imagine, but because it is violently compressing the air in front of it. So Loeb took the paper's own figures and asked how much power that shock would dissipate. An object with a frontal cross-section of 10 square metres, moving at 10 kilometres per second, at an altitude of 10 kilometres, must dissipate roughly 1.5 terawatts of mechanical power into the atmosphere. 1.5 terawatts. For scale, the entire electrical generating capacity of the United States is on the order of 1.2 terawatts. This single object, by the paper's own numbers, would be dumping more power into the air than the American grid produces continuously, for as long as it was moving. Then the second step. Meteor observations tell us roughly what fraction of that dissipated power comes out as visible light, and the answer is about 10%. 10% of 1.5 terawatts is 150 gigawatts of visible light. Over a 10-kilometre path at that speed, the emission would last at least a second, and a 150 gigawatt light source in the sky for a full second is not something anybody misses. It is a fireball that would be reported by every person outdoors within 100 kilometres, and here is the contradiction that ends it. The objects were reported as dark. That was the entire defining characteristic of the Phantom class. Completely black, zero albedo, visible only as an occlusion. Something moving through the lower atmosphere at 15 kilometers per second cannot be dark. The physics does not permit it. You do not get to have an object that violently compresses air and does not glow, so one of the inputs had to be wrong. And Loeb identified which one and quantified it. The distance was overestimated, and he showed by roughly how much, using a scaling relationship that I find genuinely elegant. The inferred luminosity of the fireball scales with the assumed distance to the fifth power. Fifth power scalings are brutal and unintuitive, so let me spell out what that means. If the object is 10 times closer than assumed, the inferred luminosity is not 10 times smaller, it is 100,000 times smaller. So he ran the correction. Move the objects 10 times closer than the paper placed them, and the same angular measurements now give a true speed of about 1.5 kilometers per second and a true size of between 30 centimeters and 1.2 meters. Loeb's own description of those numbers is that they are characteristic of artillery shells. And then the final figure which closes the loop completely. An object with a frontal diameter of 10 centimetres at a distance of 1 kilometre produces about 10 kilowatts of emission. Loeb's comparison is that this would appear about as bright as a 100-watt light bulb seen from 100 metres away, which is to say, effectively invisible. Dark, exactly as reported. Everything falls into place once you divide the distance by 10. The extraordinary speed becomes an ordinary one, the impossible size becomes a mundane one, and the mysterious darkness stops being mysterious and becomes the expected result. I want to dwell on the fifth power scaling for a moment longer, because it is the most transferable idea in this entire video, and it will serve you well beyond this story. Whenever a physical quantity depends on a steep power of an assumed input, small errors in that input become catastrophic errors in the output. Here, luminosity goes as distance to the fifth. That means being wrong about distance by a factor of 2 makes you wrong about brightness by a factor of 32. Being wrong by a factor of 10 makes you wrong by a factor of 100,000. The practical consequence is that steep power laws are extremely good detectors of bad assumptions. If you plug a guessed distance into a fifth power relationship, and the answer comes out screamingly inconsistent with observation, you have not discovered a new phenomenon. You have discovered that your guess was wrong, and the steepness of the power law tells you it was wrong by a lot. Loeb ran the relationship backwards and let it tell him the size of the error, and it said an order of magnitude. Now apply the same logic to the lunar papers, and notice how much worse the situation is. In the atmospheric case, the required correction was a factor of 10. If the lunar objects are actually near field, at a kilometre rather than at the moon, the required correction is a factor of nearly 400,000. That is not a refinement. That is the difference between a bird and a country. And here is the part that I think should genuinely give anybody pause. That enormous correction produces a completely consistent picture, with no leftover anomalies, using only objects that we already know exist in large numbers in exactly that airspace. The lunar interpretation produces an inconsistent picture that fails escape velocity, fails the visibility test, fails independent replication, and requires the existence of something entirely new. When one hypothesis needs a single mundane correction, and the other needs a new category of object plus a fleet of explanations for why nobody else saw it, the choice is not close. He also dealt with one other object in that paper almost in passing. The authors had identified a luminous variable object at an altitude of 1,170 kilometres, detected from both stations. Loeb noted dryly that this is very likely a satellite. 1,100 kilometres is squarely in the middle of low Earth orbit, where several thousand catalogued objects are currently circling, and a satellite tumbling slowly will vary in brightness in a periodic way as different surfaces catch the sun. And I want to end this part with how he closed his own analysis, because it sets the tone I have been trying to hold throughout this whole thing. He did not gloat. He quoted Oscar Wilde. "We are all in the gutter," he wrote, "but some of us are looking at the stars. That is the right posture. The impulse to point a telescope at the sky and ask what that is deserves respect, even when the answer turns out to be a shell or a moth. The failure is never in the looking. The failure is in what happens after somebody tells you that you got it wrong. And on that we have a very specific record, because the next people to weigh in were the author's own colleagues in his own building." Part 13. The Observatory Disowned It. On September 15th, 2022, the Main Astronomical Observatory of the National Academy of Sciences of Ukraine convened an astrophysical seminar. The purpose of that seminar was stated plainly. It was to examine the interpretation of the paper and the argumentation for why the observed events were precisely unidentified aerial phenomena. Boris Zhilyaev, the lead author, was present. What followed was a formal statement from the observatory's scientific council, and I want to go through it carefully, item by item, because it is the single most important document in this entire story, and almost nobody sharing the lunar claims has read it. Start with what the council conceded, because fairness demands going in this order. They described the observations as original. Nobody was accused of fabricating footage. Nobody was accused of dishonesty. Something was recorded, and the council said so. Then the findings. The processing and interpretation of results, the council wrote, were performed at an inappropriate scientific level, and with significant errors in determining distances to the observed objects. Errors in determining distances. That is the finding delivered by the author's own institution 4 years before the lunar papers applied the same method to a target hundreds of thousands of times farther away. The Council noted that the paper omitted the dates of the observations entirely. The Council noted that the paper did not indicate which of the events had been observed simultaneously from both stations, at Kyiv and at Vinarivka. That is the specific omission that makes a parallax distance unverifiable, which is to say it is the omission that makes every derived number unverifiable. The Council noted that the authors did not provide arguments that natural phenomena or artificial objects of earthly origin might be among the observed events. Meteors, objects carried long distances by wind, space debris. The ordinary explanations were not addressed and eliminated, they were simply not engaged. And then the Council's summary judgment. In the absence of a critical analysis of possible errors, of the adequacy of the models, and of the accuracy of the post-processing, the authors postulate unreasonable conclusions about the characteristics of the observed objects. The Council concluded that the publication was premature, and that it did not meet the professional requirements for publication of the results of scientific research. Then they went one step further, and this is the part that I find most striking. The Council requested that the paper be revised to state that the authors alone were responsible for conducting the independent study with no participation of the observatory. The institution asked to have its name taken off it. There is one more procedural detail in that statement worth having, because it recontextualizes the whole dataset. The Council documented that the footage had been obtained while the meteor stations were operating in test mode during scheduled meteor observations, and that the results had never been reviewed or discussed within the observatory before the preprint went public. A separate and considerably harsher assessment, attributed to the wider National Academy, described the article as pseudo-scientific in form and content, with methods full of inaccuracies, simplifications, fabrications and outright manipulations, and conclusions that were mostly absurd and far-fetched and had nothing to do with simple, natural explanations of the observed phenomena. I include that quote for completeness, but I want to note that it is much angrier than the Scientific Council's own language, and the Council's language is the more useful document because it is specific about what actually went wrong rather than merely condemnatory. Now, what happened next matters enormously. A science publication attempted repeatedly over a period of weeks to reach the lead author for comment, including specific requests for his response to skeptical interpretations of the findings. Eventually he replied. His answer in full was that the broad public interest will not allow him to debate, and that it is not acceptable to discuss scientific works. And then he added one more thing. He said he was working on, and planning, a new publication. That is the hinge of this entire story, and it is why I have spent so long on a 4-year-old episode in a video about the moon. The new publication is the Lunar series. It is the same team, using the same colorimetric distance estimation, with the same absence of parallax, the same absence of error analysis, and the same interpretive leap from unexplained to technological. The only substantive change is the assumed distance. In 2022, the assumption placed the objects 10 kilometres away, and the derived sizes came out in metres. In the lunar papers, the assumption places them 384,000 kilometres away, and the derived sizes come out in tens of kilometres, the size of the claim scaled with the assumed distance. That is not a coincidence. It is arithmetic. It is the same equation with a bigger number plugged into it, and the response to being told the distances were wrong was not to go and measure the distances. It was to stop discussing the work, and to point the same method at something farther away. So that is where the claim stands. Which leaves the honest question that I think anybody watching this deserves to have answered, and it is the question I have been building toward the whole time. If none of this is real, then why does the moon keep producing things that nobody can explain? Part 14. The moon really does flash. Because it does, constantly, and we measure it. I want to be very clear that I'm not walking anything back here. Everything I have said about the preprint stands, but there is a version of this video that ends at the debunk and leaves you with the impression that the moon is a boring grey rock where nothing happens, and that impression would be its own kind of falsehood. Things flash up there, things glow, and some of it is genuinely not fully understood. Start with the flashes, because they are the most directly relevant. The moon has no atmosphere. That single fact has an enormous consequence for anything that hits it. On Earth, a small meteoroid entering the atmosphere is decelerated over tens of kilometres of increasingly dense air, and it burns up long before it reaches the ground. On the Moon, there is nothing to slow anything down. A meteoroid arrives at its full interplanetary velocity, typically tens of kilometres per second, and strikes solid rock. At those speeds, the impact is not a collision in any everyday sense. The kinetic energy is so far beyond what the material can absorb elastically that both the impactor and a volume of the surface are instantaneously vaporized. That vapor is incandescent. And from 250,000 miles away, we see it as a brief point of light on the dark portion of the lunar disk. NASA's Meteoroid Environment Office, based at Marshall Space Flight Center, has been systematically monitoring the Moon for these flashes since 2005. The program has recorded hundreds of confirmed impact events, and here is the detail that should reframe everything about the equipment discussion earlier in this video. They do it with modest telescopes, instruments in the 14-inch class, the kind a serious amateur owns, because you do not need aperture for this. You need cadence, patience, and 2 telescopes watching simultaneously, so you can rule out cosmic ray hits on the sensor. The European Space Agency runs a program called Neliota, operating the 1.2-metre telescope at Crăiuneri in Greece, which was refurbished specifically for this work and began observing in 2017. It has confirmed well over 100 impact flashes, and Neliota added something genuinely new to the field because it observes in 2 wavelength bands simultaneously, which allows the temperature of the impact flash to be determined for the first time. Those temperatures come out in the range of roughly 1500 to nearly 5000 Kelvin. Now here is the number I've been building toward. The typical duration of a lunar impact flash is on the order of tens to hundreds of milliseconds. Read that against the papers again. The atmospheric class of objects is reported as flashing for 100 to 500 milliseconds. That is the same range. The phenomenon of brief flashes near and on the lunar disk lasting a fraction of a second is real, thoroughly documented, monitored by 2 space agencies, and completely explained. Which means that the observations these papers are built on are not describing something unprecedented. They are describing something that has a boring, well-characterized, extremely well-studied cause. The exotic interpretation is not wrong because flashes do not happen. It is wrong because flashes happen for a reason we already know. We have talked on this channel about how precisely we now watch impacts on that surface. In the video from July 29th, we went through the prediction of a spent rocket stage striking the Moon, timed to within seconds, with observers preparing to watch for the flash at a specific wavelength associated with lithium in the exhaust residue. We talked about how the Elcross impact in 2009, which was deliberately engineered and closely watched, produced no visible flash at all, and about how a mystery rocket stage in 2022 left a double crater that nobody has fully explained. That is the state of the art. We can predict, observe, and forensically analyze impacts on the Moon at the level of individual craters. The longer record is stranger, and I do not want to flatten it. Observers have been reporting brief lights, glows, reddish colorations, and localized obscurations on the Moon for centuries, not decades, centuries. These reports were collected formally. In 1968, NASA published Technical Report R277, titled Chronological Catalogue of Reported Lunar Events, assembled largely by an astronomer named Barbara Middlehurst. It listed on the order of 579 reported events, drawn from historical observing logs going back hundreds of years. Later compilations pushed the total past 2,000 reports. The most famous single case is from 1958, when the Soviet astronomer Nikolai Kozyrev obtained a spectrum of the crater Alphonsus that he interpreted as evidence of a gas emission event, an outgassing from beneath the surface. That result has been argued about ever since. Some researchers consider it a genuine detection of volatile release. Others consider it an artifact. It has never been definitively resolved in either direction. So what is the honest state of play on transient lunar phenomena? It is messy, and the messiness is the point. A substantial fraction of historical reports are almost certainly atmospheric seeing effects, misidentified features near the terminator, or the well-documented tendency of observers to see what they are primed to see. A further fraction are now understood to be impact flashes, which nobody could have identified as such before we had the monitoring programs to characterize them. And there remains a residual set of reports, particularly the ones involving localized glows and obscurations lasting minutes, rather than milliseconds, that have no agreed explanation. Outgassing from the interior and electrostatic dust levitation are the leading candidates. That residual is a legitimate open question. It is the kind of thing that a well-designed observing program could actually settle. And I want to draw the distinction that this entire video has been teaching, because it lands exactly here. An unexplained residual in a centuries-long observational catalogue, sitting inside a phenomenon that is partly understood and actively being studied, is a completely different object from a claim that fails escape velocity on its own numbers. Both of them contain the word unexplained. Only one of them survives contact with arithmetic. And one of those leading candidates for the residual, the electrostatic dust, was photographed on the lunar surface last year. Part 15. The dust that floats on static electricity. In January of 1968, a spacecraft called Surveyor 7 was sitting on the lunar surface near the rim of the crater Tycho, and it did something nobody had asked it to do. About an hour after local sunset, with the sun below the horizon and the landscape in darkness, it photographed a bright glow along the western horizon. That should not have been possible. On Earth, the sky stays lit after sunset because the atmosphere scatters sunlight over the horizon, which is what twilight is. The moon has no atmosphere. When the sun goes down on the moon, it goes down, and the sky above the horizon should be as black at sunset plus 1 hour as it is at local midnight. But there was a glow, a faint band of light hugging the horizon, right where the sun had gone. Then, in December of 1972, Eugene Cernan was in lunar orbit aboard Apollo 17, watching the Terminator approach before orbital sunrise, and he saw streamers of light rising above the horizon. He sketched them. Those sketches, made by an astronaut with a pencil while orbiting the moon, are still cited in the scientific literature, which I find quietly wonderful. The leading explanation for both observations is that the moon has weather, not air. Dust. Here is the mechanism, and it is one of my favourite pieces of physics in the solar system. Sunlight striking the lunar surface includes ultraviolet radiation that carries enough energy to knock electrons out of the surface material. That is the photoelectric effect, the phenomenon that Einstein explained in 1905 and that won him the Nobel Prize. On the sunlit side of the moon, this process leaves the surface with a net positive electrical charge. Now, the lunar surface is not solid rock at the top. It is regolith, a layer of pulverized dust produced by billions of years of micrometeorite bombardment, and the finest grains in it are a few microns across. Those grains pick up the same positive charge as the ground beneath them, and like charges repel. For the smallest particles, the electrostatic repulsion can exceed the moon's feeble gravity. So, they lift. They rise off the surface, hover, and fall back, forming a tenuous dynamic haze of levitating dust, a few tens of centimetres to a few metres above the ground. Near the terminator, where the sunlit and dark regions meet, the charging is most extreme, and the effect should be strongest because the boundary between charged and uncharged surface produces strong local electric fields. Sunlight scattering off that suspended dust is the leading explanation for the horizon glow. It matters practically, not just aesthetically. Levitating abrasive dust is a serious engineering problem for anything we want to leave on the moon for a long time. Lunar dust is sharp because there is no water or wind to round it off, and it gets into seals, abrades optics, coats solar panels and degrades their output, and the Apollo astronauts found it clung to everything and got into the cabin, where it caused respiratory irritation that Harrison Schmitt described as lunar hay fever. And here is the frustrating part of the story. This was hypothesized in the 1960s, and then it sat there. For over 50 years it remained difficult to confirm directly. Orbital missions looked for the dust and produced ambiguous or null results. It became one of those questions that everybody agreed was probably true and nobody could nail down. Which brings us to March of 2025. Firefly Aerospace's Blue Ghost Mission 1 landed in Mare Crisium on March 2, 2025, carrying a suite of instruments for NASA. It operated on the surface for a full lunar day, about 2 Earth weeks. And on March 16th, as the sun set over its landing site, it photographed the lunar sunset. Deliberately. That was a planned objective, designed to provide data on whether lunar dust levitates under solar influence, and creates a horizon glow of the kind Cernan described from orbit and Surveyor 7 caught from the ground. Then it did something better than that. The lander kept operating for about 5 hours into the lunar night, past the point where its solar power should have given out, continuing to capture imagery of how the dust behaviour changed after sunset. A spacecraft not built to survive the lunar night spent its final hours photographing a 57-year-old question. So when you hear that a recent lunar lander photographed a mysterious glow near the horizon, and that this is presented as corroboration for something exotic happening at the moon, here is the honest answer. Yes, it did. It went there specifically to look for that glow. It is dust, static electricity and sunlight. It is a genuine phenomenon that looked anomalous for decades, and it was resolved the way things get resolved, by sending an instrument to the location and measuring it. I want to hold those two stories side by side for a moment, because the contrast is the whole lesson. One anomaly, the horizon glow, was reported by careful observers, sat unexplained for half a century, was pursued with increasingly capable instruments, and was eventually addressed by putting a camera on the surface at the exact time and place where the effect should occur. The people who did that were prepared to be wrong. The instrument might have seen nothing. The other anomaly was reported, was checked by an outside physicist within hours, was formally reviewed by the author's own institution, was found to rest on an unmeasured distance, and the response was to decline further discussion and publish again with the distance assumption made larger. Those are two different relationships with being wrong. And the difference between them is not intelligence or credentials or access to equipment. It is a willingness to let the measurement have the last word, which leaves one final oddity, and it is the biggest one, and it is not about lights at all. Part 16. Made of Earth, and nobody knows why. The moon should not be made of the same stuff we are. Start with the bulk numbers, because they are measured and they are strange. Earth's mean density is 5.51 grams per cubic centimetre. The moon's is 3.34. The moon is about 61% as dense as the planet it orbits. The mass ratio is stranger still. The moon is about 1.23% of Earth's mass, which means Earth is roughly 81 times more massive. That sounds like a large gap until you compare it to other planets and their satellites, where the ratios are typically in the tens of thousands or millions to one. Relative to its primary, our moon is enormous. It is closer to being a double planet than anything else in the inner solar system. Then there is a quantity called the moment of inertia factor, which is less familiar but tells you something the density alone cannot. It measures how mass is distributed with distance from the centre. A body of perfectly uniform density has a moment of inertia factor of 0.4. A body with a dense concentrated core and a lighter shell around it has a lower value, because more of its mass sits close to the middle. Earth's moment of inertia factor is 0.331. That is the signature of a large iron core occupying about a third of the planet's mass. The moon's is about 0.393. That is very close to 0.4, which means the moon is nearly uniform. Reanalysis of the seismic data recorded by the instruments Apollo astronauts left on the surface indicates a small iron-rich core with a radius of roughly 330 to 350 kilometres, which is a couple of % of the moon's mass against Earth's third. So we have two bodies that are physically very different. The leading explanation is the giant impact hypothesis. A Mars-sized body, conventionally called Theia, struck the early Earth. The collision ejected an enormous quantity of material, overwhelmingly from the outer silicate layers of both bodies, rather than from Earth's iron core, and that debris settled into a disk and coalesced into the moon. That story does real work. It explains why the moon has almost no core, because it was assembled from mantle material. It explains the density difference for the same reason. It explains the angular momentum of the Earth-Moon system, and then it runs into a wall. The canonical simulations of that impact predict that a large fraction of the moon, often somewhere between 60 and 80%, should be made of the impactor rather than of Earth. Theia should be in there in bulk. But when you measure the isotopic composition of the Apollo samples, the moon is very nearly identical to Earth's mantle. Oxygen isotopes match to within a few parts per million. Titanium matches to a handful of parts per million. Chromium matches. Tungsten matches. Silicon matches. To understand why that is a problem, you have to know that isotopic ratios function as a chemical fingerprint of where in the solar system a body formed. Different regions of the protoplanetary disk had subtly different isotopic mixes, and material that formed at different distances from the young sun carries different signatures. Every other body we have samples from tells a distinct story. Mars is clearly different from Earth. Vesta is clearly different. The various classes of chondrite meteorites are clearly different from each other and from us. Theia should have been different too, and there is essentially no trace of it. This is a real, named, unsolved problem, and I want to be extremely clear about its status, because this is precisely the sort of thing that gets recruited into stories like the one we have spent this video taking apart. The isotope problem is not suppressed. It is not hidden. It is not a thing that mainstream astronomy refuses to discuss. It has been argued about openly and vigorously in the highest profile journals in the world for more than 20 years, and there are multiple competing published solutions, none of which has won. Some researchers propose that the proto-Earth and the debris disk remained connected by a turbulent silicate vapor atmosphere long enough to equilibrate isotopically before the Moon condensed. Others propose that the proto-Earth was spinning far faster than it does now and was struck at high angular momentum, with the excess shed later through an orbital resonance with the Sun. Others propose a collision between two bodies of much more similar mass, producing a well-mixed disk where the distinction between target and impactor breaks down. Others propose the synestia, in which the impact produces a vaporized, rotating, donut-shaped body of rock out of which both the Earth and the Moon condense. And some argue that Theia simply formed in Earth's own orbital neighbourhood and was isotopically similar to begin with. All of those are hypotheses. Every one of them requires additional assumptions or fine-tuning to work. The problem is genuinely open, and it has nothing whatsoever to do with objects at 11 kilometres per second. That is the discipline I want to leave you with. Two unsolved problems in the same neighbourhood are not evidence for each other. The Moon's isotopic twinning with Earth is a real mystery in planetary science. The claim about 36-kilometre toroids is a measurement error. Putting them in the same paragraph does not transfer credibility from one to the other, and the fact that it feels like it should is exactly the cognitive move that these stories run on. The same logic applies to the other pillar of the Moon is not what we were told argument, which is the eclipse coincidence. Here is the true part. The Moon and the Sun appear almost exactly the same size in our sky, which is why a total solar eclipse can cover the Sun's disk precisely, and leave the corona blazing around it. And that geometry is temporary, because the Moon is moving away from us at about 3.8 centimetres per year, driven by tidal friction transferring angular momentum outward. We know that rate to millimetre precision by firing lasers at those retroreflector arrays. Run it forward and total eclipses eventually stop being possible, somewhere between roughly 600 million and a bit over a billion years from now. So the window in which a species can watch a perfect total eclipse is finite, and we are inside it. That is real. But look at the shape of the window. It is on the order of 1 billion years wide. Anatomically, modern humans have existed for something like 300,000 years. Over 10 million years, which is deep time by any human standard, the Moon recedes only about 380 kilometres, which is 0.1% of its distance. On the timescale of a civilization, that geometry is effectively frozen. Finding yourself inside a billion-year window is not a coincidence that demands explanation. It is the overwhelmingly likely outcome for anybody who happens to exist while it is open. And then there is the deeper point, which is that the question can only be asked from inside the window. If the geometry did not permit total eclipses, there would be no one marvelling at their absence. A coincidence that is only noticeable to observers who exist during it is not evidence of design. It is a selection effect, and recognizing selection effects is one of the most useful habits of mind anybody can develop. While we are here, the tidal locking deserves the same treatment. The Moon shows us one face, and that gets presented as eerie. It is the expected outcome of tidal dissipation acting over long time scales, and it is not remotely unique. Every large moon of every giant planet in this solar system is tidally locked to its parent. It is the standard end state, not the exception, and in 7 days that geometry is going to do its thing again. On August 12th, the Moon's shadow crosses the Arctic, eastern Greenland, western Iceland and northern Spain, and we covered the whole event in the video from August 2nd. Millions of people will point cameras at it, which, given everything we have just been through, is worth thinking about for a second. I should deal briefly with the framework that gets offered to make the lunar base idea sound technologically coherent because it comes up every time. The idea of self-replicating machines spreading through a galaxy is a serious one. John von Neumann worked out the mathematics of self-replicating automata. Ronald Bracewell proposed in 1960 that a civilization might send physical artifacts carrying messages rather than broadcasting radio, and a low-gravity body with abundant raw material, no atmosphere, and a short transit time to a nearby planet would, in principle, be a sensible node for such a network. That is a legitimate hypothesis, and I am labelling it as exactly that. It is an idea about what would make sense if such machines existed. It is not evidence that they do, and it cannot rescue a set of numbers that fail orbital mechanics, because no framework, however elegant, repairs an object travelling at 4.5 times the escape velocity of the body it is supposedly based on. There is also an irony in invoking it here that I do not think gets appreciated. The von Neumann probe idea is most often discussed in the context of the Fermi paradox, and the Fermi paradox exists precisely because we have looked and found nothing. The framework is famous for the absence of the machines, not for their presence. So let me land where this actually goes. This was never really a video about the moon. It was a video about the difference between a measurement and an assumption, and about the fact that anybody can learn to tell them apart with about 10 minutes of arithmetic and one physical constant they can look up on a phone. An angular measurement is a measurement. A distance that was assumed is an assumption. Multiply them together and you get a number that looks exactly like a measurement and is not 1. Every extraordinary figure in this story, 36 kilometres, 11 kilometres per second, twice Earth gravity, was that kind of number. And the person who produced them, when told the distances were wrong by his own institution, chose not to measure the distances. We are living through the first period in human history when a claim like that can reach 50 million people before anybody has converted it into arcseconds. That is genuinely new. The claim moves at the speed of a share button, and the check moves at the speed of someone bothering. And the thing that keeps sitting with me is how easy the check would be. Not the arithmetic, though that is easy too, the actual experiment. 2 telescopes, a few kilometres apart, both pointed at the lunar limb, both recording with synchronised clocks on the same clear night. A bird at 1 kilometre would leap wildly between the two views. A structure at the moon would not shift at all. The result would be unambiguous, permanent, and impossible to argue with, and every piece of equipment required already exists at both of those stations. Nobody has published that observation, not the authors, and not anyone else. So that is the question I am leaving open, and it is a real one rather than a rhetorical one. In 7 days, more high-resolution cameras will be pointed at the geometry between the sun and the moon than at almost any event this decade, and every one of them will produce artifacts, and some of those artifacts will be birds and aircraft and dust on sensors and defocused rings from mirrors sitting in the middle of light paths. The footage will be extraordinary, and some of it will be misread within hours. The question is not whether anything strange gets recorded next week. Something always does. The question is whether this time anybody measures the distance before they tell us what it was,